Fortunately, we do have a fantastic presentation for our last speaker. Fatih is definitely one of the speakers that I was very, very excited about that he is joining us.
Hi, everybody.
And I am very happy that also we don't have to say we can't hear you. So Fatih, take it away. Looking forward to what you have to say.
Let's go.
All right. I was trying to figure out a way to close this out because we had so many amazing speakers coming up. And we talked about a little bit in before, and one thing that stuck with me and is there all the time is the topic constraint. As you can see, I'm the CTO. That means I have the responsibility in architecture and delivering the dream that our customer or designers come up to, and constraints is the number one thing we struggle all the time. So I want to put a small scenario up, and your customer comes in, and maybe in this case it's a fashion brand, and they want a beautiful virtual world, and it needs to stun everybody that comes in. The products will stand out. It will be amazing. Obviously, we are already in the field of interactive real-time technology. All my other partner speakers here did a great job explaining what it means. So I'm going to skip that and talk about you want to achieve something, and this is where we start off. And I will use AI images on purpose because that's what happens now in the industry is your customers come with their dream scenario to you, and you have to figure out a way to deliver it. And the greatest constraint, I'm going to take it out right away, is very obvious. It's budget. So, okay, we need to probably look for a smaller house because the Grand Empire, whatever, what you want is not something that fits the budget. But it still looks nice, a lot of fidelity, you need photorealism, so that's what we look for, and there is hardware and technology capable to deliver this experience today. But constraints come in now. The real world wants something else. It wants, okay, well, how do we deliver this? My customers need to see it. Do I deploy it on consoles, on work devices, on smartphones and tablets? That means we already need to tune down the experience to fit the current average and technology and computing power that is available on the market. Here, I use the PS4 as a reference because if you take small mobile phones and whatever, the graphics power that everybody has in their hands and tablets and on work devices on average is not that great, but you can still provide great experiences, right? But that is a limitation. You need to download things, you need to share things, you need to adapt to stuff. And the customer now says the one thing that you didn't want to hear, it needs to be available by anybody and ideally on my website. So it's exaggerated right now, but welcome WebGL. It serves its purpose. Probably not the greatest experience here to have a fully interactive temple where you want to present your products because it's obvious we have a completely different foundation and constraint in terms of what we can do. On the left, you see the computing power that Arcware offers with their 3090s, and on the right is the average WebGL render resource available to your end users. So throughout our time, to my time, to the in the industry, we always cared about where it's going to be sitting on and how the users are going to see it. Because sadly, for the artists, for all the artists here, that's your limiting factor. If somebody tells you, hey, it needs to run on an Oculus Quest, we had that. Everything feels a little bit bad because you cannot go all in on Unreal Engine and take the most out. But you heard it, there is a solution to that, and I'm going to talk today why we decided it's the right path to go. And we started with it in 2019, so it was very early. We were one of the first that did big pixel streaming projects. And what we did is essentially decided that we have to get rid of all these devices that we push to. We remove all the support. We don't do VR. Because we are in the middle of a pandemic and nobody has VR headsets. And so it was very interesting, but it also brought a lot of benefits. And the major one is the term of that your constraints are fixed now. You know what your target is. Every artist knows what to test against. The hardware is the same for every single customer that you have. It's like developing for a console, something that like an exclusive title in the video game industry, We don't have that anymore. So the environment for developers is really bad right now. You have hundreds of different devices. You have different Xboxes. You have different PlayStations. You have everybody has a different PC, and it's very difficult. It takes a lot of time, resources. Every project costs so much more money. But if you go with pixel streaming, if the use case fits, it means you have one target. You can be very fast. You can be very clear what you can achieve. And as soon as the servers get better, the whole experiences grow automatically. And a little bit about me. So I said it before, I have experience over 12 years in immersive technology. So what I did basically is I jumped in with the DK2 very early in 2014 or something, when this technology came up and was available through Kickstarter. And I also was lucky because I was next to a person that got Unreal Engine 4 on a USB stick that you needed to pre-compile. And I decided to found a company with my colleagues. It's called NoiseVR. It's a technology that we created to host live concerts within virtual reality. Over the time, it evolved out of virtual reality. So it's also browser-based live concerts with real-time visuals and a lot of users that need to be able to join the space. So my theme is creating social, multiplayer, interactive experiences. But also the other things, I founded the VR HQ in Hamburg, which is an event space, but also VR arcade that you can come by and visit. With 2 hours, you can visit a lot of different VR experiences. I founded the virtual production studio, so we did like advertising, real-time production for live streams with big LED walls. But my passion in the last 5 years was avatar-based multiplayer platform. And that's where I spent the most time in, and that's where we grew the most, or I grew the most as an Unreal Engine expert. And it's called Meadow. So very briefly, we built a multiplayer foundation, the whole tech stack from data, how we bring in content, how we connect the users to the space, how to make the user experience easy, build avatar systems, and a framework to bring in any world that you want, while also being in a multiplayer environment with hundreds of avatars, being able to talk with emojis, jump on vehicles, drive around, and that's like the base technology that we built over time. And we were lucky to have like a lot of great experiences that we were able to build on our framework. And later on, I have 3 use cases that I brought today, which I want to use to just iterate on what was the initial goal, why we decided to go that path, and what the technology allowed us to do. And I hope that brings a little bit of value today. And we just recently have a new product. Currently it's called Plaza. No multiplayer this time, but we try to revolutionize how easy it is to get into and sell, do marketing for buildings that are not yet created. So a full tech stack from browser interface, connection to CMS, and bring in building data and user technology that is brand new. It's called Gaussian splats to create experiences that are very believable, realistic, and have a great value. But I have one use case that dives a little deeper into this. So a use case that came up for us is Procter & Gamble approached us in the middle of the pandemic. And it was clear we need to replace media tours and client meetings. And because how these customers, they operate in a very personal, one-to-one manner. Their customers are big retailers. They have new products. They want to show them. So that's why they are on CES and other big environments. And the PG Live Lab is basically the top level. It's a company itself and representing all the hundreds of different brands like Braun, Gillette. But each brand acts independently from each other. But here we have an opportunity to showcase all of them and the latest and greatest. So they need to maintain a really high quality representation of their products. If the product looks like this, it needs to look like this. It doesn't make sense to have a low poly version delivered. It needs to be very precise. And the biggest challenge, it's the first time for everybody. It's brand new right now. Everybody knows Second Life, but forgot about it. And So how do we deliver something that is user-friendly and works? And over the course of many years, we expanded and built out the PG Live Lab, which is like a completely virtual platform. We solved challenges like delivering hundreds of interactive avatars into the space, live presentations, build brand spaces where you had like people jumping in avatars with historic roles, answering questions, product presentations. We had hundreds of staff members joining in and answering questions. We built like little games, and all of that was delivered through streaming because that was a way where we could reach everybody. Have low access point, and even the C-level was able to use Macs, and at that time, like something that was not standard to get into a complex experience like this. So our artists and we as a product team could deliver a fast, high quality products because we use Unreal. We could use Unreal Engine. We didn't have to go any WebGL rendering technology. And that was like a strength that we had. We were able to use all the strengths of Unreal in terms of how fast you can build and deliver basically complex projects. And one thing that you saw now in Unreal, you can do really amazing characters, interactions, complex things like video games and Fortnite. And we use the term Fortnite for business sometimes because it's just there and you just need to use it. And it's really interesting how the business industry comes to us and has like no clue about how the gaming industry actually overlaps this here. And I think Fabrice did a great job at explaining how this is like a very inspiring change in industry. Yeah, so we built a lot of different experiences here. Not much more to say about this one. Another one is a great use case for this technology because Planet came to us and said, we want to streamline onboarding because in a time like today where a lot of people work from home, it's really hard to build connection and loyalty with everyone, and we want to start on the first day. So we designed together a platform that revolutionizes a little bit how your first day of work looks like, because you can meet your other peers as avatars that also started, and you have an HR person that has a is able to guide you through the core values of the company. So here the challenge was we need to be able to develop high quality visuals and audio because it's a creative agency. They have high standards. It needs to be multiplayer. And since they have that vision and design, we need to be able to enable them. And that's where all this technology came in really great. So we built this on our Meadow framework, enabling new avatars, flying, different things like growing big and small, bringing in particle effects, using ray tracing for glass. And really the goal here was to make a great package that impresses you when you step into this world and go through it. And we collaborated with like amazing audio talent and the studio here. And in the end, we're able to provide a great software that is not just a single go, but thanks to Meadow, it's a scalable product because we built everything that can, so it can be spinned up, deployed multiple times for different departments. And Unreal and Pixel Streaming helped us to use the great pipelines that Unreal Engine has. So Cinema 4D to Unreal is something that we utilized a lot. Asset packs, as we mentioned, ray tracing is there. It allows you to create beautiful materials that are very lifelike. And since we're in the engine, and that's something that repeated over the history of using real time from the get-go, it's so easy to generate marketing material, videos, high quality renderings because everything is there and everything already looks great. So sometimes you want to have 20% more resolution, and then you can generate a video if the hardware is not strong enough, and then use it somewhere else. And since we're already in a real-time environment and created all the assets, we even did an Apple Vision Pro native project where the customer wanted to show that onboarding trainings also work on VR devices really well, and our system can combine the different users coming together. So the last one goes a little bit away from multiplayer because it's very new, but here the challenge was we need to be able to differentiate ourselves in sales. If we have buildings, apartments that are not built yet, they need to be sold out pretty fast, but in today's age, you need to convince people a lot more than you had before. So we need marketing materials. We need to be able to use everything that we have from our from the tools that we have internally, and it needs to be authentic and realistic, set in the real world. And what we built is a solution that helps come in at the beginning. Fabrice showed a great example, and I can just agree. It helps you with the initial phase of getting the green light just to build something, so we can visualize that. And it's being used for marketing materials, and in the end, you can embed it on your website just as a sales tool, so end users come in and find all the apartments, do tours. And one foundational technology that allows us to do this is called Gaussian splats. So the last 1.5 years, we experimented with what is the best way to get the real world into the Unreal Engine. And we figured out that the Gaussian splatting technology is advanced enough that it can be used. So the great thing compared to photogrammetry or reconstruction is it's much more performant. It's faster to create, and reflections change when you walk around. And I think that's the part where it's really stunning if you walk around in a scanned environment. And how it's been done is you use a video and in a specific way record your room, and AI-based algorithms create a splat, which is a point cloud that has a lot more complexity. So if that's something of interest, we can definitely meet up at a later point. I can show you how the technology works, but we were able to implement this in our platform, and the strength really comes to life as soon as you combine it with things. Because when you combine it with a virtual object, the virtual object instantly looks almost realistic because it's embedded in something that is realistic. And that allowed us to create this product because the building itself, if we would create a virtual environment, would look like a very gaming preview rendering kind of thing. But since we scan the environment and place it, the building in, it instantly looks like it's naturally in place. And I think this is a very interesting technology that we also see with Meadow, where we want facility tours combined with virtual screens. But we see in virtual production industry being used to create fast environments and pre-visualization. And I think that's one of the key aspects where Arcware also comes in, because it still requires big hardware to create complex scans and see them in real time. And cloud streaming is like there already. So we could use it to deliver highly interactive experiences that have complex scans in them. And one thing that's also important, but we've seen it, is Unreal. Using Unreal compared to other tools just allows us to import industry standard buildings, objects into the engine and save a lot of time and money by just doing that. So if you use pixel streaming and you will look at it on a website, or later you will see that there is price attached to it, and it should maybe surprise you that, or it might look expensive, but what you need to understand is you're offloading all the work from the beginning into something that is more sustainable. The initial price is much lower than if you would have tried this, deliver this in a different environment or for VR or something else. And I think that's really what I wanted to tackle on here is the constraints of the different hardware, and what experience you want to deliver is really offset by the ability to have the strongest PC available at all times. And that's where I, after all these years in pixel streaming, want to definitely say thanks to Arcware, because they build a system that actually runs and has impressive hardware. And that just means I don't have to, I have projects, and I didn't have that in the past, where I didn't look at the technical foundation of draw calls and materials and texture sizes, because the PC is so strong that all our basic flows are already enough. And I just had it yesterday. We need to move in massive objects and change them, and we just skip the optimization because nobody paid for it, and it runs. So that's a great benefit if you have like the almost best rendering hardware just there for the end consumer to use.
Matthias?
Yeah, I mean it's hard to keep up with all of the details which you're dropping. It's my ADHD brain. I have to concentrate to keep up with everything. But so maybe just a first very quick question. So how big is your team size? Just to have so in the sense of, because there's tons of different types of natures of projects which you're handling that have different, let's say, technical needs, from 3D scanning to, or let's say, photogrammetry, Gaussian splatting, optimizing CAD data for running in real time, 3D animation, rendering, all and combining all of the tech stack. So just for the people that don't know how big your company is, how many people do you have on staff, basically?
I think the first answer I want to give is that in today's age, you don't need that many anymore. Partially because of AI, but also because Unreal offers so many of these tools, and you find templates all over the place. So, but if you look at Meadow and just a general project like the Live Lab, and you want to realize that you have multiple rooms that you create and multiple environments that you have to build, or games that you program. If I take out the platform work and say the platform is there, you just need to create content for it, then a project like this can be delivered with 10 people, where you have to look at artists that create 3D models and animators and experts in level design, and then you have your programmers. But I also been able to deliver great things with just 2 or 3 people, because the way this technology works, you get really fast to a certain point. I think Unreal's greatest strength is you get to the 80% really fast, but the last 20 are very horrible. And if you look at Unity, the first 80 is very difficult, but the last 20 is amazing if you got the skill. So I think that's like why we are able to create prototypes really fast and with small teams, because you open the editor, you can do everything in there. You can, as a programmer, create a level or get a template for a level, or somebody builds a tool where you can just paint on the floor and it automatically looks great. So we're really in a day and age where it just gets better, because AI tools comes in and allows a programmer to create art, programmer to create UI and interfaces, and an artist to create programs. So I believe that's, I would say, the average team sizes really depends then on what you want to achieve in terms of complexity of the world or of your plan, but not in the, am I able to create, I will never be able to create such a big world with so many things alone. But I think it's the greatest time actually to have like small focused teams, and don't be afraid if you look at like Unreal Engine, what you can achieve there. You don't need to find 10 people to get going. Definitely not.
Then I have some audience questions. Yes, thank you. I don't like being cut up. Obviously, Fatih, the Gaussian splatting is super impressive, and that's why we would like to learn more about how you actually do it, because obviously that means that once we see something awesome, we want to be able to do it too, right? So first of all, the shots from Hamburg, was it right, that you showed, were those made with a drone? And how do you create and capture these, like how do you create the Gaussian splats, and how do you capture the spaces?
Mm-hmm.
So we actually have great video content on it that my colleague Derk created. So if you find our YouTube channel, if you just saw BizLogic, you will find more. But in general, I can say it's not that hard anymore, because it's greatly documented and a lot of people putting out a lot of tutorials to get started. And to make it simple, the Hamburg stuff is you have your smartphone and you're in the city center, and you need to make sure that when you create a video that the exposure of every frame is the same, that the focus stays the same, because the learning process does the same as photogrammetry. It understands where each point in the room is and triangulates that. And what comes with Gaussian splatting is just that it's able to do more by understanding changing in light and reflections from different points, and creating a file in the end that is very small in size, so it can be used further. So you're in the city center and you have your video camera up. You need to make sure you capture everything from every angle. So it will look funny if you use your phone, because you have to go to your knees and stand up and raise your hands. Jörg has created a beautiful technique, so shout out to him. And you can also use a drone for architecture projects. Drones make so much more sense. So let's say you want to scan the environment where you want to place your building, then you just take a very simple drone where you are able to set these settings as well. Because if, for example, auto exposure is on and you fly against the sun and everything turns bright, then your scan will also be, it will still work, but on the texture, you will see some parts being lighter and darker than others, and in the end, it will not look realistic. You fly up and down from every direction, and then you put it into the training environment. And there is something like PostShot or Volinga and tools like this out there. You can even use self-compiled ones, because in the end, it's a white paper that was released that kickstarted the industry. So on GitHub, you will also find a lot of custom tools. We are building our own custom pipeline as well, because of the different needs that we have versus the tools that are out there. But in the end, it's as soon as you have the data, currently the most format that I see the most is PLY. And the cool thing about it is you can also run it in the web browser really efficiently. So I give you the keyword super splats and play canvas Gaussian splats. They're doing amazing work. It looks amazing. You can open up in a browser and look at objects and look super realistic. Obviously, downside is you don't have an environment, you don't have interaction. It's just the splat optimized, really. And I think that's where unranging comes in. There's a lot of plugin vendors out there. And here also we have to look at our own system because of our needs. But in the end, this allows you to combine it with 3D models. And I think that's the key strength that will allow you to do more than just scanning something and then walking through it. Because here you can scan something, add virtual objects, check different scenarios. And the best thing is it's measure perfect. So that's great for architecture, right? Because if you scan something, place a virtual object in, the sizings match because the scan is accurate.
So it doesn't react in any way to the lighting setup in the 3D file. How do you deal with this?
Currently, what we do is the opposite, right? We capture a certain time of day, and then the virtual objects have to match this so it fits together. There are so many attempts right now to solve this issue by relighting the Gaussian splats. The strongest one I've seen that you can check out, because our internal things I can share, is Volinga, for example. So we already advanced quite a bit in relighting Gaussian splats. That means that you need to keep that in mind in capturing, like in photogrammetry. So if you would do a drone scan, use an overcast day with not a hard shadows. And then these technologies and these advancements, and I think in 1 year we were from 0 to hero, and I think the next 2 years we're going to solve all of these other questions as well. And then you're going to scan environment, relight it, change time of day, which is something that we want to solve, and combine it with virtual objects, and both interact with each other, right? The only thing missing is that the plants move with the wind and the trees, and that's where you, and currently we trick that a little bit by combining virtual and real world objects. But the 4D aspect, the movie aspect is already being solved. There's great research out there where a Gaussian split is real time almost with 30 frames. So we will have that soon.